Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered if you truly understand the big picture of our planet and its health? Well, this new study dives right into that. Today we're exploring a fascinating study about something called Planetary Health Knowledge, or PHK. You might be thinking this sounds really complicated, but stick with me, because understanding it might be more important than you realize for our future. So what exactly is Planetary Health Knowledge, PHK? The researchers define it as knowledge about how our health is connected to environmental systems, societal systems, and how all these things interact. Think of it as knowing how pollution affects our lungs, how farming practices impact the water we drink, or how economic decisions influence global well-being. The authors explain that PHK is seen as a vital piece of being a responsible global citizen, like knowing your part in the big puzzle of making our world a better place. Now, the thing is, understanding PHK is a huge topic. Previously, there was a big test to measure it, but it took over an hour to complete. That is a lot of time for most studies, especially online ones where people tend to drop off if things take too long. So the big question for this research was, can we create really short but accurate tests to measure PHK? And importantly, can we make multiple versions that are essentially equivalent, like different editions of the same book? This way, researchers could give the same test to people multiple times in a study without them just remembering the answers from the first time. This is where the idea of parallel tests comes in. Imagine having a few different 14-question quizzes, all on the same topic of PHK, but using different sets of questions. The goal is for these quizzes to measure the same thing just as well, with similar difficulty and accuracy. But how do you even pick the right questions to make these parallel tests? There are so many possibilities. The researchers used a really cool method called ant colony optimization, or ACO. Think of it like how real ants find the shortest path to food. They leave a trail, and other ants follow the stronger trails. In this case, artificial ants explore different combinations of test questions, and the best combinations get reinforced, leading the algorithm to find the optimal set of parallel tests. It's a smart way to solve a really complex puzzle without trying every single option. To build these tests, the researchers gathered data from over 900 people in the USA. They were given a large pool of 175 different questions about PHK, and each person answered a selection of these. This balanced approach helps make sure they have enough information to figure out how good each question really is. They started with a big item pool of PHK questions, covering 7 main areas: health, nutrition, environment, safety, education, standard of living, and political and economic systems. These questions were chosen carefully to be understandable and relevant across different cultures. After answering the PHK questions, participants also shared information about themselves, like their age, education, and importantly for this study, their political views and worldviews. The whole process had 3 main steps. First, they used that ant-inspired method, ACO, to build 3 parallel 14-item tests. Second, they looked closely at the quality of all the questions they used, using fancy new ways to measure how similar the questions were. And third, they checked if the knowledge people had about PHK was connected to their personal beliefs and political leanings. Creating these parallel tests wasn't just about picking any questions. The researchers had a whole bunch of rules or criteria for the best tests. These included making sure each test covered all 7 PHK areas, that the tests were similar in how hard they were, that they were reliable, meaning they consistently measured knowledge, and that the questions weren't too easy or too hard. They even made sure the tests would work similarly in both the US and German samples, which is pretty thorough. They used a special formula, a weighted function called phi overall, to guide the ant colony optimization process, balancing all these important factors. Once they had their 3 parallel test versions, they really dug into how connected they were. They used confirmatory factor analysis, a statistical method, to check if the questions in each test were actually measuring the same underlying idea of PHK. The results showed that the 3 parallel tests were highly related, with correlation coefficients very close to 1. This means they are indeed measuring very similar things. They also combined all the tests into a larger 42-item version, which showed even higher reliability as you'd expect with more questions. When they looked at the actual test results, they found that the 3 parallel 14-item tests had some really good qualities. The model fit, which is basically how well the test results matched their theoretical model of PHK, was excellent. The difficulty levels were very similar across the 3 tests, meaning one version wasn't significantly harder or easier than another. Now, here's a small catch. The reliability, which is how consistent the test is, was only moderate for these short tests. This is pretty common with very short tests. Think of it like trying to measure something precisely with a very short ruler versus a long one. The longer ruler will generally give you a more precise measurement. However, the 42-item version did show much higher reliability. So, it's a trade-off. Shorter tests are easier to administer, but might be a bit less precise. A really interesting part of this study was how they looked at the pool of all the questions they had. They ran the ant colony optimization algorithm multiple times, each time creating a new set of 3 parallel tests. They then checked how much overlap there was in the questions chosen across these different runs. They developed a new measure called the Reversed Adjusted Overlap Index, or ROE. In simple terms, the ROE helps them see if the algorithm was repeatedly picking the same best questions or if there was a good variety of questions that could be used interchangeably. They found the overlap was only slightly higher than what you'd expect by chance. This is actually a good sign. It means that the pool of questions was quite good, with many options that could be used to create similar tests. They also used something called normalized Shannon entropy. This measure tells them how evenly all the questions in the pool were used across the different test assembly runs. A higher number means the questions were used more evenly, suggesting a more homogeneous and high-quality item pool. Their result here was pretty good, indicating that the questions were generally well distributed in their usage. Now, for one of the most interesting parts, they looked at how PHK connects with people's beliefs and political affiliations. They found that party affiliation alone didn't show much difference in PHK scores. This was a bit surprising to the researchers, as other studies have shown links between political groups and environmental knowledge. They suggest this might be because in their specific study sample, the educational backgrounds were more similar, which can smooth out some of those political differences. However, when they looked at broader worldviews, the story became clearer. They found that PHK was moderately and negatively correlated with worldviews that are described as right-wing and dominance-oriented. This means that people who tend to favor hierarchy and the dominant group in society generally had lower planetary health knowledge. Conversely, they tested the association with climate change beliefs. PHK was positively associated with believing in climate change. This aligns with the idea that having a broader understanding of environmental and societal systems makes you more likely to accept the reality of climate change and its causes. So, what does all of this mean? The researchers successfully developed 3 parallel ultra-short tests for planetary health knowledge using that clever ant colony optimization method. These tests are designed to be reliable, valid, and most importantly, time-efficient. The fact that the test characteristic curves and test information functions, which are basically ways to measure how well a test works at different knowledge levels, were so similar across the 3 versions is strong evidence for their parallelism. This means you can use these tests interchangeably in your research. As mentioned, the reliability of these super short tests is only moderate. The researchers are upfront about this, noting that shorter tests usually have lower reliability, but they also point out that the combined 42-item version has much higher reliability, offering a trade-off between length and precision. The investigation into the item pool quality using ROE and Shannon entropy suggests that the researchers have a solid foundation of questions. The minimal overlap between independently assembled test versions indicates a good variety of psychometrically sound items, which is crucial for creating multiple, equivalent test forms. The findings linking PHK to worldviews are really important. They confirm that how people understand the world, whether they favor hierarchical structures or believe in a competitive, challenging environment, does seem to influence their knowledge about planetary health. This goes hand in hand with research showing that people's core beliefs can shape how they engage with scientific information. Especially on topics like climate change, the researchers acknowledge that having only 2 items per domain in these ultra-short tests means the coverage of each specific area is limited. For truly deep dives into subdomains, longer tests would be needed. They also wisely point out that the labels and terminology for PHK are still evolving, and their approach is intended to be inclusive. The biggest limitation they highlight, and it is a common one with short tests, is the trade-off between administering time and reliability. Researchers need to consider the specific needs of their study, how much time do they have, and how precise does the measurement need to be. Despite these limitations, the practical implications are significant. These parallel PHK tests offer a way to efficiently measure knowledge about planetary health. They are perfect for studies that need to track changes over time, like in educational settings or during intervention programs, without causing practice effects from repeated exposure to the exact same questions. They can help educators identify knowledge gaps and tailor their teaching to improve understanding of our interconnected world. In a nutshell, this study gives us a valuable toolkit. 3 parallel, short tests to measure planetary health knowledge. They've shown these tests are comparable in quality and use a novel approach to evaluate the underlying item pool. The findings also reinforce the idea that our worldview and how we see society can influence our understanding of global challenges. And here is the best part for anyone interested in this research: all these test versions are freely available online. This means researchers and educators can start using them right away to assess and improve understanding of planetary health, something that is increasingly crucial for our collective future. What do you think about planetary health knowledge and its connection to our beliefs? Does this study surprise you, or does it confirm what you already suspected? Let me know in the comments below. And if you enjoyed breaking down this research with me, please hit that like button and subscribe for more explorations into the fascinating world of psychology. See you next time on RUBIN'S Mind Lab.